Hello, this is Peter Newman. I'm a member on the ANSYS student community, and Han Yu has a question about convergence problems on a contact model. So we're going to look at that model, and typically that error message comes up, and this is what you might see. And a quick look at the force convergence tells us that the model was having trouble converging on the next iteration, and it only got 10% of the way into the load. But under solution information, the model was configured to show the last three attempts. So these last three dots, the force imbalance is plotted actually here and here and here. And so what we see is that the solver is struggling to balance the forces on this element, or back in here, or back in here. So the mitigation to fix this is to use smaller elements around there. And so that means going into the mesh and putting some mesh controls, say for sizing. And so if we put some sizing controls on the edge or the face, we can fix that. And so let's try putting some sizing controls on this face and this face, and since it's sort of a symmetric problem, this face and this face. So the default element size was 0.24 10 to the minus 2, so 0.1 e to the minus 2, and let's remesh that. So now that there's some smaller elements, it's very small elements that might have gone too far, might have put an extra 0 in there. Let's go back one, 1 e to the minus 2. So let's generate that mesh. And so those elements might have a much better chance of solving than the ones that were there before, and that's what the Newton-Raphson residuals are for. So we hit solve and see if that's good enough. I'm going to pause the video while the solver starts to solve. Well, it's already 4 in, so I'll pause it and we'll come back and look at it once it's made some progress. So this solution has made it past that 10% point. It's trying to get to nearly the 19% point, and it's struggled a couple of times, and it's cut back the step size to 3 times in a row. And that's a good point to just say, to interrupt the solution. Things are going very poorly here, and we don't need to wait till it gives up on its own. We can just interrupt and look at these plots to see where is it having difficulty. So the plots tell us that the difficulty is now on this element in the next 3. So this tells us we need smaller elements here. So we're going to go back to face sizing and put those small elements also on this face and this face. Apply. Let's generate that mesh. Maybe need that is a smaller set of elements, but another approach is use a sweep method. So let's show that. Here we're going to insert a method on this body, and the method is going to be a sweep method, and the method is going to include sweeping from one side to another. So we will tell it that we're going to have a say in which side. So it's going to sweep from this face to the other face, and we want maybe 2 elements in that direction. two elements along that direction, and we can, because it's sweeping from this side to that side, instead of that face sizing, let's take away those 2 faces with a control click. What we'll use instead is edge sizing, and so we'll insert sizing on the edge, on that edge, and that edge, and we want, say, 6 elements around that edge. So now when we mesh, we get a lot of nice elements around the corner where it was having difficulty before, and that's probably a better way to mesh this other piece as well, which would be a more efficient way to fill this and use less elements. So let's go ahead and duplicate that, but pick this body and pick this face, and generate that mesh. And that has caused, that has been unsuccessful meshing like that. So that might be, let's see, why is that? We might need smaller elements on that, so we might go back to this face sizing and control it on the edges as we had before. So edge sizing to a few edge sizes. Yeah, I think just suppressing this and clearing that and letting it go without this face sizing constraint. Nope, it's having difficulty. So let's just suppress that and unsuppress that and let it mesh. And we'll see if we can get the solver past the 20% point now. So we're going to say solve, and I'm going to pause the video while we wait for the results to get us past the 20% point. So we're at 30%, so we made it past that difficulty with the improved mesh. Smaller elements in the areas that were shown to be areas of difficulty, and here's 70%, and it's complete. So we were successful with that last mesh. Oop, I may have spoken too soon. Let's see, does it converge? Yes, on the last iteration. So it got to the end, and there's the evidence. Looks like it's where it needs to be, and there is some little stress here, but if we look at a point in the middle here, like right before it finished. There's where the stress is the maximum, and we could put more elements in this area to get a better resolution of the stress there. But that is some of the techniques to get a model to converge. Alright, that's a good place to stop the video. Bye.